السلام عليكم. Okay, I guess start. So this is the paper, and I guess this is the way. Oh, Lattice deduction transformers. We introduced Lattice deduction. Sorry, transformer. We introduced the Lattice deduction transformers. Immediate music on. Put that up a bit. We introduced Lattice reduction transformers. LDT, a recurrent transformer that approximates a logically sound deduction by projecting its latent state through a lattice between forward passes. We train on policy in a direct. We train on policy in a process that mirrors deduction in a search-based constraint solver in supervised training via domain-agnostic abstract interpretation-based approximation of a set of solution candidates. Okay, so I'm not sure what that means. They train on policy. Okay, deduction based that mirrors in a process that mirrors deduction in a search-based constraint solver. Okay. Supervised training via domain-agnostic abstract interpretation-based approximation of the set of solution candidates. Okay. An 800K parameter LDT achieves 100% Sudoku accuracy on Sudoku Extreme and Snowflake Sudoku. Okay, at a fraction of the training cost of prior small recurrent reasoners, while remaining empirically sound, the model returns a correct answer or abstains. While remaining empirically sound, the model returns a correct answer or abstains. A 1.8 parameter variant reaches 99% accuracy on Maze Hard. Okay, so it's not that, they have to push it up to 1.8 million from 8,800 to make it solve that thing. Frontier LLMs score 0% and R3 benchmarks. Okay. Yeah, of course, because LLMs are designed for words, not for. They designed this architecture specifically for what is it? Lattice deduction. Okay, figure one. Lattice deduction transform performance. Yo, hello, on the net. I gotta also link the paper so that things. I'm on Discord, by the way. You can chat directly on Discord if you like. If you would like, sorry. Okay. Introduction. Reasoning in large language models has become largely synonymous with the chain of thought paradigm. Okay, and it's this time compute extensions. Okay, and it's this time compute extensions, in which the model generates intermediate reasoning tokens before producing a final answer. Yeah. Yeah, okay. Yeah, I thought they meant something. My understanding of this chain of thought business is just that you force the model to think before 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 outputting the end of thinking token, the limiter. I guess also it's just that. Yeah, these test time compute extensions. I don't know what that means, but we can check quickly. And the references. 2 is self-consistency improves. Test time compute. What does test time compute means? Let's check this thing quickly. Oh shit. Oh shit, okay, I don't have any. So yeah, we are reading this paper, latest introduction, as seen in the title of the stream. What's this time compute? Right? Is that it? This time compute in elements. The method of computation. The model uses by generating an answer as opposed during training. Traditionally, most of them have fixed amount of compute per generated token. Input for a pass through the answer next token. Every token costs roughly the same amount of computation. Okay. The idea behind the test time compute is that the model can, I mean, if you don't count like the UV cache, the KV cache and the KV cache, sorry about cache, and I don't know, because that grows with the position where exactly what token we're talking about. But maybe that growth is yeah, exactly. That's why the KV cache is the one that for someone who is beginner level job about to graduate, he's somehow lost about choosing what study in his master between data engineering and cybersecurity. What can you give him as an advice? Well, what do you mean beginner level? But because you're talking about masters, study. Well, it depends on your background, but what I say, there are two factors that you should consider: what you actually want in the future, and what you actually has already gained. And these two things are the ones that you should really think about. What you have already gained, you should make the best use of that. You should build upon that, not just discard it. Okay, because that will be like it doesn't make sense, and it'll be not very it won't be always the optimal way of going forward. And actually you want to do in the future the things that you see yourself in doing. Okay, you don't want to force yourself into something that you actually don't want. Okay, so you should do a meet in the middle between these two things. Okay, here in the case of data engineering and cybersecurity, you should look which one actually you have already built skills for, and which one is actually maybe the two, maybe not, and which one which one is the one that you want to see yourself grow in the future, and that you are motivated and excited about. Okay, so that with this, if you answer if you look at it this way, look at it this way, it will be your decision. You won't regret your decision. Or yeah, I hope. Okay, let's go ahead. Every token costs roughly the same amount of computation. The idea behind this time is that the model can spend more compute on harder problems to improve performance. Simple analogy. Chain of thought. No, it doesn't make sense to me. No, tell me the technical details. Refers to any mechanism that increases computational work during inference to improve performance. The key idea is that instead of using a fixed forward pass per token, the system performs additional computation that scales with problem difficulty. That's the baseline standard autoregressive inference. For transform with parameters data, okay. This probability of the next token. Generation consists of run one forward pass, produce digits, sample or choose the next token, repeat. Okay. For a model with n parameters in a sequence L, inference cost is roughly proportional to OLN. Okay. Okay. The important point, compute per token is fixed. Okay. Roughly. Using KP caches. Of course, obviously. And also there is even using KV cache, it isn't that simple, because you're still doing you're still computing, okay, this makes sense. The L here it comes from that multiplication with the KV cache that has been already computed. Okay, that with the cache. Maybe. Okay, I can accept this. Shinata as this time compute. Should suppose that the answer could be produced in 20 tokens. In 20 tokens. What is wrong with my reading? Can't read. Without reasoning, question, answer, with chain of thoughts, is it token? No. The model is literally performing hundreds of some evaluation. Oh, 1 moment. Back. Oh, baby. 1 moment.
Welcome back.
Sorry, I wasn't here.
Yeah, no worries. I joined late and suddenly someone joined you.
Ah,
But I
yeah,
knew
yeah, yeah.
you
It's a
when you.
cousin.
Yeah,
He's coming from not here, and I had to welcome him. He's still me though, but they are. I told them that I have a stream going. And
okay, no worries.
okay, yeah. So I'm reading now this paper. I'm still actually in the beginning. Did you check it? Yeah. Just it's a
I
paper.
have.
It's a paper from very recent, from last month, and it's from an AI startup about theorem proving and that kind of thing. AHMED.ai. This lab. And actually, I just found it on Twitter, and where is it? And I figured it's something interesting that I want to look into. So that's why this is where does this where does all this originates from.
And do you have an overview? What is this paper about? Like.
Yeah, they train transformer on what is it? On directly solving graph problems. At least this is how I understand it. Lattice deduction. They solve it. They train it to. They train it this way, and they achieve 100% solving Sudoku. The thing here, are you familiar with transformers?
Yes.
Yeah, so instead of having like text tokens, my understanding here is that the input is actually a graph, a lattice, and
Okay.
so it's not they have it's a specialized model on them, and they achieve 100% accuracy on solving Sudoku.
So
that's just.
So like they taken as an input a graph, but how is the graph?
Yeah, that's the thing that I want to look into on the paper. This is maybe this is the author from INEX explaining what it is. Introducing lattice deduction transformers and 800K parameters. One thing that I'm doing with these streams is I'm trying to improve my speaking skills and reading skills in English. So that's why.
Oh,
yeah,
it's really nice.
I'm
But
still.
your reading skills and.
I'm still very bad at them, but yeah, you know.
I wouldn't say so. It's very actually good.
You're just too kind.
No, I'm not being kind. I'm being realistic.
Okay, so an 80,000, thank you, an 800K parameter loop transformer that reasons like a SAT solver. So this is the thing that has took my attention, because a SAT solver. Are you familiar with SAT solvers?
SAT solvers.
They SAT solver is basically you give them a Boolean constraint, and they look for you for a combination of true and false to satisfy that Boolean expression. I don't know if there is something called Z3 solver made by Microsoft. That's let me show you. It has a nice website. Very nice.
I think I had a conversation with someone about. We were discussing, what is it called? Oh my god, I forgot it. That one language for logics.
It's probably this. Maybe. Let me show you this. People use this actually to solve chess. Or chess. I've seen a really great example of this, but it seems like it's not here. Yeah. So, yeah. Sets of this should be a really nice introduction for them. So, check this one. You give it
But
an x as an int. Sorry.
it's just there is a language for writing, predicaments, and it's for logic. It was very famous. I forgot it. It's
For
okay.
writing
Sorry.
what?
Carry on. Carry on with your example. I will find it.
Okay. So yeah, you define the variables. This is Python, by the way. It's a Python library called C3. You define your variables this way, x and y. You see, and it has a function. This library has a function named solve to find you a solution for these constraints, that x is positive and y is negative. X is bigger than 2 and y is less than 10, and the equation that x plus 2 times y is equal to 7. And the solve will give you actually a solution for this, for x and y, for possible x's and y's. See, it's for solving expressions basically. It solves expressions.
There was another one which is very famous, and it was there even before Z3. And it's used for logic, but I forgot the name. I was actually using it with someone where we were trying to build what is it? This her kind of AI. So we would go the output of the LLM will go through this tool to ensure that it validates certain rules that we defined. And for example, if we ask it delete or execute a shell command, it will check with the rules that we already predefined, and it doesn't go through the LLM at first. So it goes through that logical thing. But I have a very
it's exactly the same thing, I guess. It's very probable that it's the same thing. And it's a language that you said. Yeah, this library is actually, it's a language. It's possible there is a language before Z3, but Z3 is the most popular now. I guess. I think.
Yeah, when I mentioned to that person that library, they went out of their way and tried to find an alternative, and one of them was actually Z3.
Oh, okay, yeah.
If I can only remember what was the one.
Yeah. So yeah, it's about these kind of things, and you can do actually a lot of things with them. For example, here you can use it to solve a Sudoku, or this is not chess, but it is a problem called 8 queens. It's actually on CSS also, this problem, and they solve it here with C3. It's a constraints problem. It's a problem where you are given a chessboard and you're given 8 queens, and you're told the question is that you find possible configurations for the queens to be put on the chessboard where there's no conflict with the queens. You see? Is
it the same problem in CES, or?
Yeah, it's the same problem.
Another.
It's the exact same problem. You implement an algorithm to solve this problem. You will come up with possible solutions. Or I think you count amount of solutions with an n by n chess. Yeah, I think, if I'm not wrong, but it's the same thing. So yeah, the thing that
sorry, the language is called Prolog. You probably know it.
But isn't that one general purpose? Okay, it's a logic programming language that has its origin in artificial intelligence and method for improving. Okay, interesting. So
the thing we did was actually very interesting because we got some good results, meaning our her, it's like Jarvis in Iron Man, but like it's,
I know her.
Yeah, so it's a bit more it follows reasoning. It's not just like the random output of a LLM. There's a logic layer after. So yeah.
Interesting. And how did this project go? What happened to it? Where did you
This
guys?
we got like, you know, like even before what was it called, that one famous you know what, yeah, I'll be back. The thing is, I have a memory issue.
Yeah, same,
What was
same.
the name, what was the famous it was like with this crab thing, I forgot.
Open claw.
Yes, open claw. Like even before open claw, but I noticed that open claw also started in December, and we also started in December, but we didn't like act on it and really get motivated to do it. But it was basically the same thing, but we were thinking OS level. And so yeah, we were thinking, is it possible to create like a microkernel where it already embeds the LLM? And you need to think of okay, it should be easy to update, and also it should be flexible for people if they want to use an online one like OpenAI or Cloud or whatever. Yeah, we added this. I think, I don't know about OpenClaw, I don't know about the architecture, but I think it basically is taking screenshots, right, and checking like how to move and things. But this one I was using my Mac, and we were trying to get the use of you know, like for people in special needs, like you have a tree for access, like what to click on whatever app that you have. So we were like, instead of taking screenshots, we were taking that tree, and it was not actually easy to navigate that one, but it had a better results. Like it's been, I don't know, 2 months, 3 months. I haven't went back to it, but
Yeah, this is really interesting, and the fact that you guys use probably, yeah, I mean, some constraint solving or something like that, logic programming. I guess. How does that fit in this exactly? The
but
usage of. Huh?
my friend though, he used the Z3 if I remember correctly. I don't know how he used it, but the thing is, like, you ask your AI something, it will generate an output, right? For example, you can just tell it create a folder. But the output, for some reasons, instead of doing that, it will decide to delete another folder, for example. So we will check the logic of what we.
It will, sorry. The output, what will happen to the output?
This is just like a wild example where we
Okay.
ask our her to create a folder, and instead of that, it's decided to delete it, for example.
Okay.
So like there is like this safety net using Prolog to see, is it really logical? Saying we want to create this, we have this this statement, and there is that statement from LLM, and we see if it passes the rule or not.
Okay. I kind of see.
Yeah, and then we decide whether to
The
execute.
difficulty though will be converting the text statements to logical expressions or something like that.
Yeah.
For Prolog or C3 or any constraint solver to be able to understand it in.
Yeah, there was this layer that does this.
Okay. That's actually.
Sorry, Aziz, but I have to work on
Okay. Yeah.
a thing, but I will just be there listening to you.
All right. Okay. So let's continue. So they kind of okay. So I was saying that this this I guess is one of the authors, and yeah, let's continue with the paper. Let's check with the paper. Okay, introduction. Reasoning in large language models has become largely synonymous to the chain of thought with the chain of thought paradigm in its this time compute extensions. So yeah, I was here with this time extensions situation. I had a bit of I was checking what does that mean exactly. The model is literally performing hundreds of extra transformer evaluation. If a transformer layer performs Then generating 500 reasoning tokens means executing the entire stack hundreds more times. This is the simplest TTC, time test compute scaling law. More reasoning tokens implies more flops in price, better accuracy. Empirically, this works surprisingly. This works surprisingly well. I still got the feel that this is just some jargon for just saying we are just outputting text token, some more tokens in a phase of reasoning, and forcing it to not select the delimiter end of thinking token before actually even though before outputting a certain amount of tokens. Okay, you get the confidence only by you make sure you reasoned enough, let's say. I guess this is just what they are saying. Okay, 3. Self-consistency. Instead of reasoning one reasoning trajectory, generate k trajectories, then aggregate. Path 1, answer 42. Ah, okay. Choose 42. Yeah. Sure. Yeah, you are just research instead of linear reasoning. Yeah, okay. Tree of thought, mathematical, Okay. Verify I guided reasoning, a separate network. Yeah, I guess he is going in a way. This is I guess it's relevant to us now. At this time, scaling laws. One of the most important recent findings is that the performance often follows predictable scaling curves with inference compute. Very roughly, accuracy is a function of test time flops, similar to training scaling laws. Loss is a function of training flops. I still don't get what this time means. Okay, from an optimization perspective, ordinary decoding performs one pass implies one answer. This time, compute turns inference into an optimization process. Question: search over reasoning trajectories implies search over reasoning trajectories implies select high quality trajectories, and then not implies that answer. Okay. So I think this time means the time before the reasoning time. The choices took has that the choice. How can I phrase this? The choices to take in the reasoning phase. Okay, either with this chain of thought or with this best in sampling. Wait. Yeah, you get it. Okay. Here he has put he did put numbered lists without saying what this list is, but let's continue. Let's go ahead. Okay, and it says some compute extensions, in which the model generates intermediate reasoning tokens before producing the final answer. Yeah, okay. In contrast, automated logical reasoning procedures operate in close analogy to discrete fusion models. Oh, by iterative refinement of the partial information state. In diffusion, information is partial in the sense that some tokens are masked refinement proceeds by progressively unmasking them. We can then view logical solvers as special case of discrete diffusion procedures that aim to recover an element of uniform target distribution over solved solutions. We can then view logical solvers as a special case of discrete diffusion procedures that aim to recover an element of a uniform target distribution over valid solutions. Okay. In contrast to the broader non-uniform distributions over plausible outputs, one commonly studied in the diffusion literature, it is then natural to ask whether techniques developed in the automated reasoning literature transfer to diffusion style algorithms and conversely. Okay. Just double checking something here. In contrast to the broader non-uniform distributions of plausible outputs, more commonly studied in the diffusion literature. Okay, not getting that now, but it's good. Consider reasoning from the perspective of abstract interpretation, which models information states as elements of a lattice with a top T representing no information. Every solution is still possible in the bottom element, with representing inconsistency. Okay. Which models information as states of elements which models information states as elements of a lattice with a top T representing no information, and a bottom representing inconsistency. No solution remains, every solution is possible. Okay. By the way, for those who does not know, lattice here is the lattice in the algebraic in order theory. It's a partially ordered set where it's something like this. Yeah, this kind of thing. This is a lattice because you can take joints. There is two operations: joint and meet. Okay, a meet is when you take the union of, for example, for the case of subsets, when you take the union, and a join is where you a join is the union here, and the meet is where you take the intersection. This is a lattice because the union of y and c is yz, and the intersection of xc and yz is c exactly. Okay, but this is what is called the lattice. There is another. It's actually a partial order set where you can take upper lower bound, least upper bound and least and the greatest lower bound, where these two are always exist, and you have these two operations, meet and join, and you have of course the respective order. Hey, here. Okay, so concretely, let's see what they mean. Deduction is a process that descends from the top, from every solution is possible place towards more informative states. Okay, a state that collapses to T signals no valid solution remains. The procedure is sound by design but incomplete. A deduction step may fail to derive true fact. The procedure is sound by design but incomplete. A deduction step may fail to derive true fact but never derives a false one. Okay. Concretely, we use a recurrent transformer whose latent space is projected to and from a lattice representation between forward passes. My sound levels I'm reading are a bit mixed up. Concretely, we use a recurrent transformer whose latent space is projected to and from lattice representation between forward passes. Recurrent transformer whose latent space is projected to and from lattice. Okay. We call this lattice deduction transformer. The interpretability of the abstract domain lets us leverage symbolic search processes at both training and inference time. On hard problems with logical structure, LDT exceeds comparable reasoning transformers with smaller models and less training. On some domains, it further achieves empirical soundness given a sufficient training budget. On some domains, it further achieves empirical soundness given a sufficient training budget. The search either returns a correct answer or abstains. It's never incorrect. We make 4 contributions. First, an architecture that projects a recurrent transformer's latent space onto an abstract lattice at every iteration. Okay. Turning each forward pass into a sound detection step. Second, an on-pulse training procedure where lattice evolves under model's on forward pass. Oh, interesting. This is interesting. This is really interesting. I'll come back from Maghrib. Go and pray Maghrib and get back. But we are onto something. This is something. Yep. So we'll be back. Guys, I'll just mute my microphone here. Okay.
Welcome back.
Hey, welcome. You too. Okay, so yeah, where was I? The contributions. Yeah, so first, let me just go back again to the contributions. First, an architecture that projects a recurrent transformers latent space onto abstract data at every iteration, turning each forward pass into a sound prediction step. Second, an on-policy training procedure where lattice states evolve under the model's own forward pass, keeping training states in distribution, which with search states encountered during inference. I didn't catch that yet. An on-policy training procedure where lattice states evolve under models known forward pass, keeping training states in distribution with search states encountered during inference. Let that sink in for a moment. For myself, catch it here. What does that mean though? Training procedure, not training, a non-policy training procedure. The lattice states evolve in the model's own forward pass, keeping training states. Okay, keeping training state in distribution with search states on content and inference. Okay, that makes sense, I guess. It just means that there is a policy of training that keeps lattice states here. Actually, the lattice represents. I should invest in a scratch pad, in a pen for drawing. But let me do. What is the website for drawing? Xcali let me just intuitively draw what this is about, so I can keep it. But then, basically, let me grab. Let me grab this one actually, not this one. Okay, this one. Okay, so here basically this is the top. This is of course the bottom. And here, things here represent any solution is okay, and which is no information has been known, because any combination is a valid solution. So we don't have any information, any useful information. There is no useful information at this state, at this thing here, at this node. And each node here represents yeah, let me put this in a graph so everything is clear. Let me put this in the illustration. The nodes represent where is the node? Yeah, a node here is an information state. Okay, yeah. Okay. So write in another font. I don't like this font. This font. Okay, so this is the place where any information is okay, and this is the place that there is no information at all, no solution remaining. They said remaining here, but لا هي already العربي داين والله حمدين حلقه في كمان. Okay. ما بعرف عليه. So here basically which represents inconsistency, let's say inconsistency, that you provided the solution. In my mind, what I'm imagining in my mind is that we are trying to solve, for example, we have a problem, Sudoku. Sudoku is basically we are given an initial matrix, given initial matrix goal, and the goal is to complete the matrix. This is basically Sudoku. You are given an initial matrix with some entries already filled, and your goal is to complete the matrix. So an information state will be a node here. You are given a node here, and what's your no. What does it mean? What does this mean? What does this mean? Well, any solution is okay in Sudoku. Will correspond to an already filled Sudoku. Okay, an already filled Sudoku, or yeah, I would say that. I will say an already filled Sudoku. And no solution remaining is the case where the matrix itself is impossible, or there is some inconsistency within it. For example, you have broken a rule of Sudoku. It should be this case. And what they are trying to do is go from the top state that any solution is okay to go downhill. I'm not sure. Let's continue reading, but this is just to brainstorm. I think. Hope what I'm saying here makes sense. If there's any question, you can ask me. Although I don't know. I'm not even sure yet if that's what they are trying to say, what they are doing. Okay, so third, the alpha operator, which aggregates the valid solutions. This is an operator that they will introduce, which aggregates the valid solutions which aggregates the valid solutions still consistent with the current lattice state. Which aggregates the valid solutions still consistent with the current lattice state. This is the alpha operator. Okay, this replaces our training in a regime we are not aware of in prior work. One policy yet is supervised by a domain-agnostic, state-dependent target. Okay. This places our training in a regime we are not aware of in prior work. I don't know what that's mean, but let's continue. Fourth, an experimental characterization of the training test compute trade-off in learned sound inference, showing that additional training shortens inference search by orders of magnitude. Okay, the rest of the paper is organized as follows. Section 2 reviews how much time has I used. It's okay, it's good. We have now, we are 1 hour 25 minutes on the time, so it's good. The expected time is 2 hours or 2.5, 3 hours something. We are midway actually. Okay, so the rest of the paper is organized as follows. Section 2 reviews the related work. Section 3 provides relevant background on abstract interpretation in lattice structures. Provides relevant background on abstract. Oh no, okay, yeah. Okay, Section 4 details the architecture, training and inference of the lattice deduction transformer. Section 5 provides an evaluation of the lattice deduction transformer against comparable reasoning transformers and frontier LLMs. Finally, we conclude and discuss future directions in section 6. Okay, how long is this related work? Okay, good. We can read it quickly. Okay. Beautiful. Okay, so not so long, manageable. Hopefully we can make it in time. Related work. Our approach draws from research on small recurrent models that outperform far larger ones on hard reasoning problems. Adaptive computation time introduced variable iterations neural computation for recurrent networks, later adapted to transformer by universal transformers. The hierarchical reasoning model uses dual loop recurrent architecture. The tiny recursive model shows that a two-layer with recursion can outperform it with a smaller model. We built directly on Sotaku, a recurrent transformer specialized for Sudoku. LDT can also be characterized as a neurosymbolic method, combining a neural network with the lattice representation that search-based constraint solvers use to track partial information. Okay, SATnet and learning module theories embed MaxSat and SMT solvers as network layers, preserving a hard neural symbolic boundary. Closer to our setting, machine learning has been applied throughout the abstract interpretation pipeline. Neural abstract interpretation trains sound differentiable and abstract transformers. LAAT learns a neural policy that prunes redundant constraints and synthesize sound transformers via LLMs with SMT validation. I guess this is what Warren Farnell said, that LLMs with SMT validation. Is that right? Still here? I guess this is, if you're watching, this is what you said. Earlier work targets the control loop. Let me screenshot that file. Let me just quickly screen that for you. Okay. Earlier work targets the control loop instead, selecting sound transformers via or learning by widening thresholds. The 3PM, the discrete diffusion generalization of masked language modeling iteratively commits information about partially masked sequences We recast this process as a fixed point computation over a lattice. The 3PM, in fact, admits an arbitrary token transition matrix, which can be instantiated over tokens that themselves form a lattice. Closely related in the spirit to our setup, though, we do not develop our method as a diffusion procedure. Several recent diffusion variants push in this direction. For example, our AMDM reintroduces backtracking by allowing already generated tokens to be remasked at inference time. Prime relaxes the masked and unmasked dichotomy by letting tokens occupy intermediate states between the top and the concrete value. Yeah, what I'm imagining, you are coming from uphill into and looking for doing simplifications until you end up in a place that you cannot go downhill anymore. That's my vague understanding, and I'm not seeing yet how it connects to the problem Sudoku that we have. Okay, so HDLM organizes the vocabulary into a refinement hierarchy, whose forward process, abstract, upward, and reverse process. Sorry, I mixed that up. I've mixed that up. The vocabulary and HDLM organizes the vocabulary into a refinement hierarchy, whose forward process, abstract, upward, and reverse process refines downward. Okay. Each can be read as moving along partial information ordering in our framing. That ordering is the lattice. Okay. Now let's go to the meat of the subject. Abstract interpretation. Introduced by Kusot and Kusot, is a framework for, so they are not the originator of the thing. Introduced by Kusot and Kusot, it is a framework for sound approximate reasoning over systems where exact reasoning is computationally infeasible. Originally developed for program analysis, it replaces costly computation over concrete domain C with efficient computation over an abstract domain A. While guaranteeing soundness, any property established in the abstract holds in the concrete. Okay, soundness comes at a price. A reasoner over A may fail to derive a true fact, even when one is provable in C. A loss of completeness. In finite domains, completeness can be restored via research procedures. Propositional satisfiability algorithms such as DPLL, DCL, and Stalmark's procedure can be cast as sophisticated search-based refinement operators on an abstract domain. In the canonical setting, the C and A are both lattices. With the order encoding precision. The lower elements are more informative. The top is less informative. And the bottom is the most informative, often denoting inconsistency or impossibility. Okay. Because the most important information that you can get is the information that is impossible to solve it. Okay. Okay. The two domains are though I'm still wondering. I'm trying at the same time to see what is my how does this translate to the Sudoku case again. But still, the transition between nodes in Sudoku case cannot be putting a new entry, a value in a new entry, in a remaining entry. I mean, because yeah, a step may be valid, but it will be a locally valid step, but it may not be it can be a step that will gives an impossibility afterwards. See, that's the issue with Sudoku. Or maybe maybe you can, a step can respect the rules, but it can be a dead end at the same time. It can give you. Okay, so that's exactly what they are doing. That's exactly what they are doing. They said that you can you may not find a solution, but yeah. So my analogy here was completely right. You start here from the initial Sudoku that given the initial matrix, and you do steps downward by filling by doing a step in the game, a valid step again, of course, respecting the rules of Sudoku, and you just go downwards. You have many possibilities at each step, and you pick one of them and go downward. At a certain point, you may so it's not actually a lattice. It's not a lattice because yeah, it is a lattice. It is always a lattice. It is always a lattice, of course. It is a lattice. But anyways, that's not important or important, whatever. But I guess this is exactly it. This makes sense. This makes sense. You start from the top of with the initial the given Sudoku problem, the initial matrix, and you go downward by filling an entry on the Sudoku matrix. And that step should follow the rules. Okay. Going this way, you will end up at two possible places: a complete game, meaning that you have a complete matrix, meaning that you have solved the Sudoku, or a matrix that cannot be that is a dead end, that you cannot, it's not complete, but you cannot do any other move without breaking the rules, okay, without losing, meaning that the only downward thing, it's a valid point, but the only downward thing is the bottom. Okay, so okay, that makes sense. This is actually also still very, there is no something groundbreaking with this. This is just a formulation. Now the interesting idea is how they connect this with the transformer. To what they claim is that at each pass of the transformer, a decision will be made by the hidden state at that point. The hidden state at that point will actually represent the new step done on the lattice, if I understand correctly. Okay, so that makes sense. And where were we? In finite domains, completeness can be restored via. I was here. I read this already. The canonical system. Okay. Often denoting consistency or impossibility. The two domains are linked by an abstraction function, the alpha, that we have seen somewhere. The alpha operator. We have seen that somewhere. I don't remember where, but something up. By an abstraction function, the alpha from the concrete to abstract. I still don't know what the hell is concrete and abstract here, but Just play along. In the concretization function that goes backward, which form an adjoint pair, a Galois connection. In the sense of lattices, let's just review what a Galois connection means. Lattices, Galois, connexion de Galois. Let's check. Okay, a Galois connection, especially in order theory, a Galois connection is a particular correspondence typically between two partial posets. Galois connections find applications in various mathematical theories. They generalize the fundamental theorem of Galois theory about correspondence between subgroups and subfields, discovered by the French mathematician Paris Galois. A Galois connection can be defined as on preordered sets or classes. Okay. This article Okay. This article represents the common case of posets. The literature contains two closely related notions of Galois connection. In this article, we refer to them as monotone Galois connections and antitone Galois connections. This is the first time I see antitone, the word antitone. A Galois connection is rather weak compared to order isomorphism between involved posets, but every connection gives rise to an isomorphism of certain subposets, as will be explained below. The term Galois correspondence is sometimes used to mean a bijective Galois connection. This is simply an order isomorphism or dual order isomorphism, depending on whether we take monotone or antitone Galois connections. Okay. Galois connection is weak. Okay. A monotone Galois connection between these posets consists of two monotone functions. Okay. Such that for all A and A and B and B. Okay. In this situation, if F is called lower adjoint of G and G is called okay. Mnemonically, the upper and lower terminology refers to where the function of application appears. The term adjoint refers to the fact that monotone Galois connections are a special case of adjoint functors in category theory. Okay. Yeah, sure. بكلي ترانسبوزي F شو الرسالة الثاني. أنت عندك هنا you have here F on the left side and you transpose it to the other side. You get G. Okay. The term adjoint refers to makes sense. The other terminology is encountered here as left adjoint, respectively right adjoint. Okay. Nice. This is somehow makes sense. This makes sense. Okay. Beautiful. Okay, so let's go ahead. Let's continue. Okay, so Helmstedt function, which form an adjoint, wait a minute. One other thing though. They don't need to be bijective, right? If it's a bijection, if it's an order isomorphism, then the inverse will be evidently the what is it? A Galois connection, trivial Galois connection. But you don't have to be that way. It doesn't have to be. The interesting cases where it's not a bijection. Okay. We form an adjoint pair, a Galois connection. This adjoint condition ensures that properties profit over A hold over C. Okay. We refer in more in-depth formal exposition. We differ more in-depth formal exposition to a self-contained mini tutorial in Appendix A. Okay. To illustrate, Sudoku consider Sudoku puzzles. A Sudoku puzzle is a function from square matrix to from the square 1 to 9. Oh no, sorry. From a square 9 by 9 matrix to 0 and 1. Assigning each digit column row pair to a number. This is a Sudoku puzzle. To reason about a partially solved puzzle, beautiful. They said from the beginning a partial information. This part here is about a partial. Each node is a partial information state. I omitted information state or something. Information. A partial by iterative. Okay. What do you mean, man? What is this thing? Yeah. Okay, so information states, and here are partial. You go downhill with partial information state. Makes sense. Okay, so a solved puzzle is a function. Okay, assigning each digit to assigning a digit to each row column pair. To reason about partially solved puzzles, you want a representation that captures uncertainty about which complete grid is correct. A natural choice is the power set lattice, where G offers the set G of all possible grids. Okay, elements of C is the set of grids still considered viable via an element of C is the set of grids still considered viable given what we know so far. We order C by inclusion. Smaller sets are more precise. Yeah, beautiful. This makes sense. I hope this makes sense also to the viewer. If there is any question, I can maybe answer. Try to explain. A natural choice of abstract domain for Sudoku is to associate each cell the digits still considered viable. A natural choice for abstract domain for Sudoku is to associate each cell the digits still considered viable, collapsing all inter-cell correlations. This is the concrete domain. The concrete domain is yo, what's up? We're reading this paper. I've sent the link, I guess, on the YouTube comments. Yep, I did. Oh, hello. We're having viewers. Okay, so nice. Another choice. Let me drink. So this is good. We are cooking. We are going not so bad so far. Another choice is the power set of the lattice. This is the natural choice for representing a partially ordered puzzle. A representation of uncertainty about which grids are correct, which grid is correct, which is just subsets of grids. You will have sorry, yeah, sets of grids, which is yeah, okay, of complete grids. Wait a minute. Another choice is the power set of the lattice, and it's a power set lattice over the set G of all complete grids. An element of C is a set of all grids still considered viable given what we know so far. Wait a minute. For all complete grids? What do you mean all complete grids? Because it should be all valid grids, not all complete grids. We order C by inclusion. Smaller sets are more precise, and the top accepts no information, which is all the set, and bottom records that the puzzle is unsolved. Another choice of abstract domain for this is the concrete domain. Another choice for the abstract domain for Sudoku is to associate with each cell the digits still considered viable. Is to associate with each cell the digits still considered viable. Collapsing all inter-cell correlation. We call this abstract domain the grid power set lattice. Okay, A is the set of functions between okay, that associate each cell a subset of numbers, of possible numbers, any possible number. Ordered pointwise, so that A prime is a subset of square subset of a square less than A if and only if A prime of C is in okay, yeah, you just order by the pointwise. See, makes sense. Makes sense. You're just refining on options of on cells for each cell, which is the pointwise thing. For each cell C, the top assigns every cell the full digit set. Okay. Okay. So this is the abstract thing. Interesting. And the bottom is reached when any cell's candidate set becomes empty. Nice. Very nice. Sudoku rules become sound abstract deduction operators on A. Okay. Each step removes candidates without rolling out valid solution. Naked singles and hidden singles are two simple examples of such operators. What does that mean? When the deduction operator is itself learned, this becomes a trade-off between train time, compute, and test time search, which we characterize empirically in section 5. When the deduction operator itself is learned, this becomes a trade-off between train time, compute, and test time search, which we characterize empirically in it's just the story of train time, test time search, test time, compute, and test time search. Okay. This is the test that comes from testing the model. Okay. This which we characterize empirically in section 5. Okay, this so far so good. Methodology. We focus on problems whose solutions can be expressed as fixed length token strings. Okay, over vocabulary feed. So the solution space is S from 1 to K. It's a set of functions from 1 to K into V. For instance, for instance, P in a big P, norm P is a subset of S. What is big P? Okay, P is a problem and norm P is the solution of the problem. That's what you mean. Solutions of a problem, the set of solutions. Okay, and the solution a solution is a function from 1 to K to V. That means a solution is a K vector in V, right? I guess yes. This is just a vector of a K vector. A K tokens, a sequence of K tokens. This S set. Yeah, I guess that's correct. Let's okay, norm P is in the node set of valid solutions. For P and big P. Okay. P is a problem, and norm P is a set of valid solutions for the problem. We do not assume access to a closed form description of norm P. Only that samples from norm P are available for each training instance. Okay. Following abstract interpretation, we take the concrete domain to be the power set lattice C of S, the power set of S. Okay, and the abstract domain to be nice. So this is a generalization of the Sudoku situation. The Sudoku situation is exactly this is generalizable. This is actually surprising. This is surprising. But no, wait a minute. G here, we didn't use G in the construction of the abstract domain in the second part. We only used G here, and we didn't also specify G exactly. What is G exactly? We didn't mention that. G is the set of these functions or what? Yeah, I guess yeah. G is the set of all these functions, because these functions are the complete grids. But there is an issue though. There is an issue that the concrete ah. But it's not actually a full power satellite lattice, because I have to have an order that respects deduction, or am I wrong? Or deduction is constructed by having the abstract domain and the concrete domain. The concrete domain contains only the valid solutions, and the abstract domain contains the reasoning or the steps where the place where you can do steps to reduce possibilities. This is fun actually. This is interesting. I should get some place to write notes or something. Yeah, I guess I should do that. Let me wait a minute. But that's not easy. There is a what is it called? Yeah, diagrams, LaTeX, not LaTeX, not stupid LaTeX. We all hate LaTeX over here. We don't like LaTeX. Fletcher, exactement. Fletcher
Sorry,
is what
can
I'm
I know
looking for.
why?
Why exactly? What about LaTeX?
Yeah.
Well, because typist is better. It's old. It's something old. We should move on. I mean,
What is better, you said?
typist. This one.
Types.
But you know,
Can you show examples?
I'm just kidding. Huh? Examples.
Yeah.
Sure. Typist for LaTeX user. This is actually really nice. This is really nice to show you the difference between the two. It's very simplified compared to you see this LaTeX Tech BF strong. In types you just do it like the way you do it in Markdown. And emphasis you just do underscore to make it italic. And the links you just put the link directly. And you see, it's very simple. It's the way it should be. I mean, I shouldn't hard to write codes. It should be as simple as the complexity should be handled by the language, by the compiler, not by the user. See?
So you go by the Zen of Python.
Exactly. It is really like you see. To write this is one of the reasons that made me hate. Well, not hate, but I don't like LaTeX, because this thing, when you want to make just a simple list, you have to do these shenanigans.
Yeah, I remember that.
Item And in types, simply you just dash list of dashes, and that's it.
It's very similar to Markdown, as you said.
Yeah, and you can do a lot in it. You can make functions in it. You can write programs in it. You see, there are for loops here. You can do for loops. See the way you do for loops?
Yeah.
Yeah, so there's a lot. This article is really good. It shows the difference between the two, between
Okay, let me just
Lattice.
type it somewhere.
Yeah, I'm gonna send it to you.
Thank you.
Yeah. So yeah, what brought me to this? I wanted a way to visualize my what I'm yapping about here. But hopefully this is a library for making diagrams, but I don't know if it's yeah, it's not so simple. It's not simple at all. It's complicated. Best I can do is just to did you follow what I was maybe what I'm saying is not so
I just hear the enthusiasm. Sometimes you're confused, sometimes you found something interesting, intriguing. So I heard all the emotional thing you went through.
Okay.
But I wasn't following the logic because I'm working on my presentation, so I'm just
okay.
yeah, listening
Good
to
luck.
you. But of course, when you finish your live, we can just like summarize your key
okay,
findings.
yeah, sure. Okay. So yeah, continue on the thing. So what I was doing, yeah, this abstract and domains thing, abstract and concrete thing. It is an interesting idea. Let me write that here. Of course, I don't like also the okay, let's zoom in a bit. Wait a minute. Okay, so a central idea here, or an important idea that they base their thing on, is the abstract domain and the concrete domain. Concrete domain. In abstract domain, you have, for example, for the case of Sudoku, the game Sudoku, the abstract domain is simplified by, is symbolized by each one of them is a lattice. Okay, these two are lattices, and the what is it? The abstract domain. Sorry, the concrete domain. Let me start with the concrete domain here. You go here. You go here. You go here. C is the, what is it? The power set of G. Where G? Power set of G. Can I make this italic? There should be italic here. No italic. This way. Where she is the space of functions between 1 to 9. 1 to 9. space of functions between 1 to 9 to this is a space of all complete grids, of all valid games, also of all solutions of sudokus. Okay, so this is basically a map between okay, the space set of all valid solutions. Coming right back in a second. Right back. Right back. 1 minute. I should though double check this one because I'm not sure if this is the set of valid solutions. So I'm gonna put this here. Okay. Man out of. Let's put that there, but however, let's go ahead. Let's continue. And the set of and the abstract domain is also it's basically it maps games again, which are these squares. It maps them to a set of possible possible steps, possible values, okay? Which is basically the subset of of 1 to 9. Yep. Okay, so now in the general case, that's the case of Sudoku. In the general case, you what you do is you take C as taking a key factor, which is symbolized this way, to a vector of vocabularies, okay, which is basically v1, v2, and k tokens. This is k tokens, and this is a set of k tokens, okay, and this is your concrete space, all k tokens, which invalidates what I've said earlier about this being valid. They don't need to be valid. They are just there. A set of all complete grids. Okay. Now I have answered myself, and A will be simply it will be a k vector as well. No, yeah, exactly, k vector as well, but this time of next possible tokens. Simple and easy. Simple and easy. PV. Yeah. Next possible set of possible actions to take. Let me just say it this way. Like set of possible digits to put. In that's it. Yeah, so each one of these is a lattice, and going forward, this is organized pointwise. So going forward, taking a step is reducing the possibilities. Is by definition reduction of possibilities. And in the concrete domain, taking a step is the trivial way. The order there is just ordered by subsets. Same goes as for here. Wait a minute, how does it go? Yeah. This is the power set of this thing. This shit. Yep. Okay. Nice and beautiful. Yeah, so now we got that out of the way, we can continue. Let me just put lines, beautiful lines here, and here as well, here as well, here as well. Here. Okay. جميل جدا. We order A pointwise inclusion. We've seen that. With meet and join defined pointwise. Okay. The two domains are linked by abstraction function. Wait a minute, what does that mean? Okay, so there is a function that goes from one side to the other side, which is called the abstraction. You take a complete grid and you map it to a trivial thing there. That's my understanding, at least. Is that what they said? You take a complete grid. Yeah, the mapping will be Wait a minute. Yeah, sure. Okay. Nice, I get that. I get that somehow. Okay, and coming from and coming from abstractions, you get your map will be taking the more precise and sound detection operator on A, for instance, is given by the most precise and sound detection operator on A, for instance, peak is given by. Okay. Ah. جميل جدا. Okay, so let's go back. Abstraction عندنا وضحت الأخبار شوي. بعد الحين عدلوها يعني ألفا اللي تمشي مع عند سي شور A. Okay, is defined by alpha of S. الحين شو كان يعني يكون ستربيسي هنا من راسي. Is defined by alpha of S. It's going to boost the visual. It takes a subset of خروجوا K tokens, okay? وليه تباس تعطيهم the trivial thing, right? That's what I'm guessing. Trivial thing, which is just will be the map in E. I mean, I can do this. I can do this in types in its more beautiful. Let me do what is it called? This series paper PDD. Let's call it PDD paper deep dive. And take note dot type, and let's do types preview. Let's write this hi, and let's do types preview, which gives us this thing. مش بذلك من الوقت. C'est pas mal. 2h23 مثلا 30 minutes de stream. C'est pas mal. نبعد دينوسيون قمنا شوي فارقين يصاب. Size 1.2, and what I'm gonna define else and set page عنها marginها auto to yeah. whatever. Okay. So what was I gonna say? What was I gonna do? What was the thing? Columns here are 3, of course. Two columns. One is 3 columns, sorry. 3 columns, sir. And yeah, I don't need to reformulate that. I don't need. I just need to concrete. كريت domain عندنا فيه C is equal to the power G, where G is equal to the set of 1 to K to V. وهذه هي set of vectors of VK. Okay. Abstract domain. Rolling. These sounds I'm making now. So this one will go from here to set. Okay. This is also the set. I can do, yeah. To actually to over what exactly? Over V. Yeah, exactly. Okay, so this is the Galois connection. Alpha, which is symbolized by alpha. L'alpha et le quoi? Et le gamma. Alpha going from C, from the concrete, right, to the alpha is going from concrete to the abstract, and it is defined by taking a subset S and mapping it to the mapping of taking an integer E to the set of what exactly? To the set of Yeah, to all evaluation at alpha of functions yeah. Yeah, exactly. And this should be exactly what they wrote. This should be exactly what they wrote because it's the most trivial way of yeah. اوكي جميل جدا جميل جدا. And on the other side, beta is the dual, the adjoint mapping from A to C and taking from that thing a function, okay, or a subset of functions. A member of the abstract thing, which is a function, which are functions, and here we are mapped to the function we map this to what? Okay, so this will take an element of the abstract domain, which is a function, which is a list of subsets, and we will map each element of that list of subsets, map each subset to no, that's not what you're doing. You're mapping the whole subset of list of subsets. Very tricky thing, very easy thing, but you'll map that to what is it? To this C space, to an element of this C space, a subset of she. Okay, and how will you do that? You will simply having a function of having a subset of functions from one. Yeah, here you map it to a subset, actually, to the concrete space. And the subset will be a subset of these functions, okay? That will associate I, an element of V, okay? An element, sorry, yeah, of V, exactly. Which is map I to what? ماذا يا ترى؟ You map a subset of functions, a subset of sorry, what the hell? What you're mapping is actually a function itself. Okay, you're mapping a function, not a subset. Mapping a function into a function that will give you actually subsets. A subset, sorry. Okay, so you can evaluate this, but evaluating this will give you actually a subset. But you don't want a subset, you want an element. Okay, that is it. Okay, so let's walk this slow. So see, alpha is actually just taking simply a subset and outputting on the space of on the concrete domain. The elements of the lattice actually are subsets. Okay, we just have a stupid lattice, a trivial meaning lattice, a simple lattice. It's just subsets. But on the abstract domain, what we have actually, the elements are functions, and these functions are k vectors. Okay, same deal. And these are ordered by pointwise because their value are the value of these functions of these vectors. Their elements are subsets. So we do an order there pointwise by subsets that are, by their elements. Okay, so this is okay. This is the picture that we have. The mapping alpha from the concrete space to the abstract space, from the space of subsets, simple subsets, to the space of abstract things is by taking a subset of what is it called? What is it again? of functions or of k vectors, a subset of k vectors or functions to the subset to the function that gives so linking this with functions. I have a problem myself with the connection between switching between functions and vectors. Let's stick to vectors. I think they are more easy to understand. We map alpha maps subsets of vectors to or sequences, k sequences, to in the abstract domain to sequences of sets that has what exactly? Yeah, so we're mapping subsets. So yeah, exactly. Okay, yeah, I understand. I did understood this at the first time. We're just mapping k vectors to other k vectors to subsets of k vectors, or sets of k vectors to a k vector that contains sets that are this is wallah stupid. Let me show you. For example, عندنا something like this. Let's just say whatever, something like this. Okay, alpha will actually map this to this vector 1 4 to 5 واللي يصير في تكبر particular cases تفهم خبر كاملة. This is alpha. This is the beautiful alpha. This is the simple alpha. alpha تعدلها مستحيل كامل قالش. بيتا gamma صار تعدل. gamma اللي تكبر عندك for example ها كتيرها. ما قاعد in bijection ولا شيء. gamma normal مش تعدل. gamma اللي تكبر What did they do with gamma? I'm curious now. Sorry. We are mapping this not to one vector. We will كان مخلط اليانا. We are mapping it with a set of vectors. A set of vector that has it is a set of vectors that maps this. Wait. Oh yeah. So it maps it to all of the. Yeah, it's just the bijection. It is a bijection, because if you map هاني شوي. Okay, في Lattice كاملة بصفتها هي bijection. This thing is a bijection. okay. Well, this is what we are doing here. In this yeah, it's okay. Yeah, beautiful. وهذا مودي هذا داته في university السابق. نو هذا أكبر من ذاك. هذا أكبر من هذا فيه for example هذا فيه كومبينيشنات الآخرين. فيه 5 par exemple 6. اوكي يقيس انا قاعد قلت اودوني نكتم 2 سكات الحلق الكبير وذا الصال الأول ما عنده مشكلة. الصال الأول لا توقف لا مانير إيفيدانس أنك تجمعهم كاملين تخبطهم بالأصل الأول ما كان إيش تسوي. هاك تمشي مع عند ألفا تمشي مع عند the concrete or the abstract. concrete مع عند abstract يعني injective. أوكي والله injective زاد يعني وي عندك طريق واحدة يك واضحة له. إما قماصة عند الابستراكت شور كونكريت عندك a lot of things أكثر من اللي you don't land where you were initial. You land, you do land, you do in fact land where you were. Alpha composed by gamma تعطيك والله الناس اللي فاهمين ذا بيك برينز حق والله طبوا عليك. والله قال إن نيومان عن رواية تطبع عليها. The more precise sound deduction operator on okay which is which together the most precise sound deduction operator on A for instance P is given by okay. For instance, P is given. Okay. جميل جدا. هذا مولي هذا is interesting to note. هذا is interesting to note. It's important to note. Deduction of P. Is alpha something gamma norm P alpha sect or enter at okay. Deduction. operator. Operator, which is a mapping from what to what. From the concrete in the concrete, right? No, not right. Abstract, short abstract. Allah, interesting. Okay. So this is a mapping with abstract, negative abstract. Okay. Indeed, informally, DP refines A to keep candidates that satisfy a C value solution. Okay. Our goal is to train a transformer to approximate P from solution samples without ever computing norm P explicitly. Set of solutions for problem explicitly. Architecturally, we encode the lattice structure as a tensor and use input and output projections between the abstract domain and the transform latent space. Between the abstract domain and the transformer latent space. Okay. Architecturally, we encode the lattice structure as a tensor and use input and output projections between the abstract domain and the transformer latent space. Use the input and output projections as between the abstract domain and the transformer. We encode the lattice structure as a tensor. We use input and output projections between the abstract domain. Okay. D'accord. Algorithmically, we use the same iterative search process at training and the first time, which we found critical for keeping the transformer in distribution at interest. Okay. Architecture for grid. Structural problems such as Sudoku, the position indices 1 to k identify as cells of 2D grid. K is equal to 81499 Sudoku. In the abstract domain, A assigns candidates set from a PV to a cell. We refer to this instantiation as grid power set lattice. Lattice encoding. We represent the grid power set lattice as multi-hot encoding. V binary sigmoids per cell. So 9999 photon 729 sigmoids for 99 Sudoku. See figure 2. Okay. Okay. جميل جدا. Okay, I agree on that. That's a representation for subsets. Okay. Which is again exactly the set of the abstract set. Yeah, definitely. So okay, solutions y are 1 hot 1 bit life per set in the abstraction alpha over a set of solution reduces to bit level OR. Okay, for variable topology puzzles, topology puzzles, where not every grid position is part of every instance, an additional read-only mask per cell which positions are impossible. For variable topology puzzles, where not every grid position is part of every instance, an additional read-only mask per cell marks which positions are impossible. Okay, that makes sense. We use this for snowflakes too in section 5.2. We give bottom dual representation. The first is implicit. Is implicit in the candidate encoding. A cell with an empty candidate set is the natural representation of bottom in the power set lattice. The second is an explicit binary segment attached to CLS. We got 3 minutes. I guess, can I finish this in 3 minutes? I guess not. Looks like we're gonna keep the rest of this to the next stream. Although I don't like to keep many papers on many streams. One paper with many streams, but yeah. I mean, I can continue until 20. أنا بدي بداية التيم غبت شوي. Donc yeah, let's go. Let's continue. We can continue. Let's see. The second is an explicit binary segment attached to a distinguished CLS token. And then CLS, let me show the banana. Any take a here. CLS meaning in email. This stupid guy, how many had okay. CLS meaning in items. More items, whatever. Classifier token, okay. The second is an explicit binary sigmoid attached to a distinguished CLS token, which we train to fire on any satisfiable state. On any unsatisfiable state. At search time we okay, جميل, yeah. The first is a set with an empty candidate encoding. A set with an empty candidate set. A set with an empty candidate cell is the natural representation of okay, yeah. The second is an explicit binary segment attached to the distinguished CLS token, which we train to fire on any unsatisfiable state. At such time, the deduction tightens the lattice states forward. We treat either an empty cell or a CLS sigmoid above theta CLS as conflict that triggers backtracking. We treat either empty cell or CLS sigmoid above theta CLS hyperparameter theta CLS. Okay, I see. As a conflict that triggers backtracking, carrying separate representations lets us train two heads with different losses discussed below. Okay. Okay. Let's have something. Okay. This makes sense. Okay, so we're starting from the bottom and going up. Oh no, we're staying. No. What am I saying? We're starting with the problem and trying to solve it. Lattice transfer encoding in transformer. Surviving candidates are highlighted. Eliminated candidates are great. Okay. Okay, so we are going with the abstract. This is actually nice. This is nice and beautiful. Abstract makes sense as a wording for that. But there is a thing with the mapping here. Okay. Yeah, فعلا ما قلت von Neumann. Yeah, von Neumann. We don't understand mathematics, but we get used to it. We don't. Young man, in mathematics you don't understand things. Get used to them. This is nice. Okay. Eliminated candidates are great. Okay, that makes sense. All this makes sense. C'est bon. The model is recurrent transformer closely following stack. A stack of 4 attention layers is unrolled for 16 internal iterations, with output iterations the output iteration L becoming the input iteration of L plus 1. طبعا يا عاقل. We reinject the input that is encoding at every iteration as a residual signal. Each iteration اوكي عندك الكورنت ترانسفورمر ما انك تعدل البلوك وتم ما انك الا تو انبوت اوتبوت تقدر يتم تعديل الريزيدوال ماتيريال يقعد ماتيريال كورنت. Okay. I don't know why you are doing that, but that's alright. You can do that if you want. We inject input lattice encoding at every iteration as a residual signal. Each iteration emits its own candidates and conflict logics. Conflict logic هو CLS الأول. الآخرين they are okay. ما شفت your loss شنبتو غير I'm following with you. At tuning time, every iteration is provided and contributes equally to the loss. Each iteration is provided and contributes equally to the loss. Okay. At the inference time, we read out only the final iteration. Position is encoded. Okay, so you are. Okay, ما انك لوسك ما هو simple. تقبل لوس على you do losses on you take loss is constructed on the intermediate steps also. Okay. At this time we read out only the final iteration. Position is encoded with a learned 2D positional embedding added to the input. For the larger 13 by 30 maze grids, we additionally apply 2D row inside attention. Okay. Okay. For the 2 solve loop and step operator. Those design, yeah. The design those more if you don't. ما بعض يعني yeah, let's see. Solve loop and solve operator. We run the same solve procedure algorithm at training time and inference time, which ensures that the distribution of lattice states the model is trained on matches what it encounters at the inference. Almost read it correctly. Okay. Our step. Okay. Did that sink in though? Okay. Our setup shares similarities with classical supervised fine-tuning on policy distillation and reinforcement learning. As in the latter two, the training distribution is generated by the model's own rollouts and supervision is state conditional. As in supervised fine-tuning, the target y. Oh. Look at this, good job, keep it up. Yeah, see you. Come on, Vanilla. It's already 3 hours, but let's finish this thing. We gotta finish it. Thank you for coming. Okay. Damn. Okay. We run the same solve procedure at training and inference time, which ensures that the distribution, the lattice states of the model is trained on matches what encounters at inference. Okay, right. As well as the training distribution is generated by model's own rollouts and supervision is state conditional. The training distribution is generated by model's own rollouts and supervision is state conditional. As in supervised fine-tuning, the target y is computed from data, which we do domain agnostic in a domain agnostic manner via the abstraction operator. This gives strong per setup supervision rather than sparse trajectory level reward or an approximate teacher signal. Self setup is a stochastic search that repeatedly applies the step operator, moving down the lattice with deterministic deduction and random matching. This process repeats until a step identifies either a solution, a conflict, or a solution. Termination is guaranteed because the lattice is finite and each step is strictly decreases the allied candidate count. This outer loop structure contrasts with recurrent reasoners like TRM and contrast. Okay. Post auto loop passes latent embedding between steps. Our passes through the lattice itself. Ours passes through the lattice itself. We do not currently propagate gradients across solved steps. We do not currently propagate gradients across solved steps. Though combining the lattice with okay. With the theorem, Sharon star cross step latent is natural direction profitable. A single step is supervised. A single step is supervised. We run the recurrent transformer, which rolls out its 60 eternal iterations and proceeds per candidate confidences at each grid cell and CLS conflict signal. We then eliminate every candidate whose confidence falls below a threshold. You call that theta CLS, yo. In the resulting state, if the resulting state is neither complete signal solution nor flagged inconsistent, we pick a uniformly random multi-candidate cell and pin it to a single digit sampled from softmax over a live candidates at temperature T decide. At training time, the conflict and solved flags are verified directly against at inference time, we test model CLS prediction and the empty cell test. Okay, this solves. Is it for both training and inference? Okay. Initial lattice state, ground truth, solutions Y, empty and inference. We do step. Update Y by one optimizer step on L. L ما جاش من هنا. Conflict sorted X prime X prime. اوكي لس طبعا لس. اوكي okay until repeat until makes it step operator on the step operator نفسه. lattice X require lattice state X granted Y empty and for step. Okay candidate and CLS logits at every iteration. What is F, yo? What is F, man? Bij with sigma Bij is less than theta elimination. Set okay, threshold elimination. Okay. اوكي اف تيتا عندنا هي ترانسفورمر، هي ترانسفورمر نفسه. ها يسبا يس should be. This is the candidate in the CLS logits. هي CLS هتعد واحد. اوكي at every iteration makes perfect sense. هذا هو اللاتيس عند iteration candidates و the CLS at every iteration. nice. اوكي يقبض تالي منهم، ديروا سيف وديروا بيت. اوكي كونفليكت فراسي كان تيتا سي سيجما سي أكبر من تيتا اس بر واحدة منهم for some cell of x or for some cell zero alive or for some cell of x prime has zero lives. okay ونتي عاد zero alive candidates. okay makes sense. That's okay. That's okay for us. And at every cell of x prime has exactly one alive candidate in not conflict. Yeah, sure. Yeah, sure. Sure, no problem, sure. Yeah. Use iteration average logits and ground truth. This is in training. It's training into the if the ground truth, if it's solvable. Yeah. Okay. Ground truth in training ground truth is not empty. Okay, this is the case where we are in training. If in training B will be averaged over all of the steps. Why so? Why is that the case? I don't even know. Okay, and y hat will be exactly the grid, the meet between the grid and the in the abstraction of these wise. أنا interesting عندي background الناس اللي معدلة هذا 1 2 3 4. These are four people. This is interesting. قبل ندخل لور background شنو بيلي. This is two different fields like actually orders and lattices and stuff. And here Manum, although they mentioned that some other people have done this thing. Okay, y hat is the meet between x and alpha of the abstraction of yeah, okay, y is consistent. Okay, the ground truth are consistent with x. Okay, yeah, as it should be, as it should be, as it should be. Okay, compute loss y hat the b's and the c's. Conflict if no y is consistent with x prime. Okay. Okay. X prime is a singleton matching some y in a, okay. If not conflict and not solved, branch, same pin, one cell, sample pin, one cell. Pick if not conflict and pick I star uniformly at random from cells with bigger than 2 by candidates. Pick I star uniformly random from cells. Ah, okay. If not conflict and not solved, yeah. This is a branching. Sample D, softmax of Vi star divided by theta decide. Okay, this is a temperature over a live candidate's I star. Okay. Okay. Pixel I star to D star. Pencil I star to D star. Wait a minute, what does this mean? In X prime, 0 all other candidates off. Okay. Yeah, okay. Yeah, it will decide at I star. Yeah. From the ones that have a lot of candidates, you will just decide to sample and pin. Yeah, one cell. Okay. You do this at each step, so that no, this is okay. Wait a minute. Okay, let's go ahead. Let's just read something here. It's not complete singleton. If I pick a formula random, it's a candidate cell, pin it, a single digit sample, and submax over the live candidate at temperature. At a temperature theta decide. Theta anomaly theta to decide at training time. The conflict and solve flags are verifiable and verified against and verified directly against y. At inference time, we trust model CS prediction. At inference time, we trust. Okay. Yeah. Yeah. Okay, let's design. Let's go. Yuppie. Let's design. The candidate simulation conflict loss. By the way, جبرنا نقول هون computer loss. This function computer loss. It takes y hat b and c. The prediction. which is y hat. Right. There's not a prediction though. The prediction is this. But this is yeah, this all this is related to loss. Let's go. The candidate elimination and conflict detection heads sit at the opposite ends of soundness and completeness trade-off. Candidate elimination must be sound along the eliminated candidate is irrecoverable, while conflict detection must be complete. A missed conflict can stall search or lead to returning a answer. We supervise every one of the 16 internal iterations with 3 loss terms. Loss of PCE L as asymmetric PCE between. What does PCE mean, man? Hi, are you alive, man? You're not even alive. نشوف يلا يرد فيك لبسيك هاي. Yeah. BCE binary cross entropy. Okay. It's binary cross entropy. So we just yeah. Okay. Let me get some water. Let me get some water and I'm coming back. Yep. Why? Some useless, man. Hello. Okay. So yeah, we supervise one of the 16 internal iterations with 3 loss terms. Where did they get this 16 from? Candidate iteration maybe sound okay. An asymmetric PCE between sigma of PL and y hat. my hat again is the grid. Okay, with positive class weight W plus and 3 and negative class weight W minus. Penalize. Yo, Ahmed, what's up? How are you doing? To penalize final, we are reading the paper. We are so far 5 pages in, but we're almost done because the evaluation part is not the consuming one. The consuming part is just the algorithm itself, the implementation that they have done, the design, the methodology, as they say. Where are you from, Ahmed? من أين أنت؟ So we surprise everyone of 60. Yeah, I've heard that. To penalize false eliminations more heavily than false retentions. Yeah, okay. Okay. Yeah, okay. ما حق أحمد شو واسي شيت ايوه يكرم بس انا شفت كومنت راقنا رفعته باليوتيوب الفيديو مالي عرفتك يا اخي عرفتك احمد باي ذا واي في ديسكورد اعتقد اتكلم عنه ذاك هو ديسكربشن. انا عندي سيرفر ديسكورد قد تخش في كانوا حد يركتيا معايا قال I'm just here like by myself. كنت تخشون تتكلم لايك. I understand everything. What do you mean you understand everything? No, I'm not teaching. I'm reading this myself. I'm trying to understand this. This is a research paper. And I'm not teaching. But yeah. ادخلك شو ديسكورد راهو بالديسكربشن عاد عندك ديسكورد والله لا زانجي مسدك عليك يا اخي. Yeah, learning, yeah. Asymmetric BCE is between okay, yeah. Okay. And Discord is for gamers. Don't you game though? Okay, Discord not for gamers. You just create your community for whatever, for your YouTube. أنا عندي community YouTube channel في اسمه هذا. فهمت؟ For live streams account. Symmetric BC between that and LC and loss of entropy at okay. CLS okay. Loss of CLS is asymmetric. Okay. Yeah, for sure. Okay, I'll make an account. ناصر صح تبي تشبه يا اخي من قريب. ما اللي قاعد راح مستلعبني شبراك قاعد تخش كال شبراك شو الأخبار symmetric oh man my mustache is so big but what can we do symmetric BCE between sigma okay and LCEL cross entropy parcel assert max and cross entropy on BL at the cells y hat has single alive where y hat has a single alive candidate. Yeah, so it's a I think LCE helps the model to learn faster. Okay, the total loss is this over all layers. Interesting. Yeah, as we expected. Interesting. At inference, we eliminate candidates whose probability falls below threshold theta elimination, and match it with the natural ratio induced by the asymmetric loss. This outperforms training with symmetric BCE and tuning theta element post hoc. We know y in big Y is still consistent with X. Yo, you're in. No, I was fooled by Discord. Okay, we know y is still consistent with X. The surviving set is empty, and y hat collapses to okay, which will push every candidate sigmoid toward 0 and overload BCE with conflict detection pressure. The lattice remains. The lattice contains many representation of an empty solution set. Today is my birthday, of course I don't party. Oh, happy birthday, man! Happy birthday, man! I'm gonna change that actually to happy birthday, Ahmed. That's the title now of the video, and staying with the title. Happy birthday. Happy birthday to you, Ahmed. You should get a wife. you should get عندك سوا دي الصورة successful عندك cats. Dog, not yet, but it's not the important thing. The important thing is obvious. You should do it. Good. Okay. happy birthday. الله يطال عمرك برو. بصحة وخير. When no y is still consistent with X, the surviving set is empty and y hat collapses to okay, which will push every candidate sigmoid towards 0 and overload the BCE with conflict detection pressure. The lattice contains many representation of empty solution set. We pick one that lives further up the lattice by catching the last non-empty by-hats per chain, you inducing X what is it, meets Y prep as the BCE target once the surviving set becomes empty. Yo, who's that?
عليكم.
وعليكم السلام.
خير تعز يا رباز.
مرحبا ياك لاباس؟
موس يا خير والله لا خير.
بخير بيك. شطاري؟
ما شاء الله تم ستريمي دراك
يوتيوب؟ يس. ما عرفتك بسوق بعد بخير بيك. عارف نعرفك ريل لايف ما نعرف.
انا والله انا متعرين الالعاب هون في ديسكورد.
وي متذكرك مرة خشيت الليلة زد والله.
ده مرة.
ايه قد قاعد انت بدي تصير صف حق. والله محمد.
حق محمود والله.
محمود
ياسرين
بعد. اللي قاعد انا تنتيت محمد فيديو محمد ياسري يصير احلى.
والله لباس شي ترمشي زين.
شو باسيك لباس يا خير.
اللهم لك الحمد الله على الحمد. شي بخير.
صح راني صام مستنطحن مع هذه بابي ونتي هذا شر. الباس بعد موفي يعطينا موفي ستريم او بعيد حتى بيلي اختار ذاك نوع الستريمات يعودوا تمهم لي ميتي بيلان قلت ماشي لينا 10 سوايع غير انا اختار لا نقعد هذا الشيء
تم ذاك نتعدى ذاك نوع بارتي
انا نختار وفيها زي المره واحده
بلاصه. اوكي
سيرتو ذاك هذه سيري ثانيه سيري انا عندي اختيار ستريمين عدلهم واحد سبت
انا قط مره خلص لك من ستريمات على يوتيوب. ان شاء الله يعطيك صح. والله يعطيك صحة ما شاء الله فريمون.
ميرسي
يعطيك صحة.
راك بعد عندي اسمه برنامجين في ستريمز واحد السبت واحد الحد. السبت للكودينج والحد الحد اللي هذا بابيات ريشيرش والله توبيك معين نقرانه نوع لايف ستريم.
يعطيك الصحة ان شاء الله.
قال السبت للكودينج السبت البارح الوقت هذا قال الاثنين ياك يعودوا يعني الناس قد تسوي معك تماشى معك معني بو يفهم تعدل الوقت في ليميتي ماكسيموم زي 4 ساعات. غير هاي راكت يعني تقدر فيها نختار وفيها دور بيه الوقت يعني مش قاعد تسوي كثير قريبة.
لا تركت كاتري الحكم.
تركت اياها 3 كاركتروا هي ماشي.
لا حقيقة أنا كاتري 4 سواء.
والله اش ما سيل.
اللهم لك الحمد. الله لك شي بخير الامور الحمد لله. اللهم لك الحمد الامور زينه.
حاجه لي من جماعه السايبر سيكوريتي والله من
انا والله نقراها فضمي.
اوكي في احتمال كبير نلحق شيك موقتين على التلفون.
والله لا مرحبا بك وسهلا زاد في دار الديدان. زاد تنتظركم.
تعدل لي
جاي. انا نعدل في بوخم.
اوكي
أبوي بوخم هنا سنقرأ بالألمانية.
ألمانيا شو وصلت مع سنة واحدة مع اللغة والله.
اللغة شت هي أب تو فهمت. لكن رجاج تستمر توفي عندك سنة. بالنسبة لهم عطيناك سنتين. عندك الحق في سنتين توفي فيها اللغة. هي ناحية لغة صعيبة ما نكذب عليك. غير مودي في نفس الوقت ذاك نوع عادي تنقرأ وتنعرف. فهمت ما هي رواية ذاك النوع أكبرهم قلت نيو درجاج مش تمر مع راسه ويعطيها وقت وقد يوفي هذاك النوع في سنة زايدة شوي. فهمت يقعد مودي رجاج ذاك النوع ماشي بشهور قد يوفيه في سنتين زايدة. بدي هي عنده امتحان اللي تعدل له بدرك تجرب امتحان ساعة تعدلوا وتفرق امتحان ساعة حق ما هو تم تقرأ نيجري تعدل رايدك كان رواية أخرى تمارك عن رايدك ناس تتكلم لك عن البيئة والله امتحان يجيك توبيك ساكنة معين عن البراكين. فهمت راك نوع
I see.
حق ذاك نوع رواية ذاك نوع حق رايدك ذاك نوع شيء رواية سترينج. فهمت
I see.
غير نهاية المطاف ذاك نوع تشوفه. فهمت
I see. تركتها في 4 سنوات المسيح عندنا ما لحق. ليسانس ولا
اللي
باشلر
هما
ولا تتعلم ماستر
ما
سنتين؟
أنا نعدل ماستر.
يا دونك سنتين.
أنا وايد سنتين. أنا أصلا باشلوري قبل من تونس. أنا أصلا من
آه
جبالة تونس
ما
كنت.
شاء الله الحمد لله صراحة.
كنت أصلا في تونس. كنت ذاك النوع أقرأ في نيس فاكس، فهمت.
بون.
كنا أصلا قاعد بداية عليه دخول مجال ذاك النوع، فهمتني، سايبر سكيورتي. شي اللي مجال ذاك النوع كان زين عندي، كنت باسيوني بيه. عندنا ذاك النوع في الكليبات وشي، كان دايما من
والله
الشغل،
تونس متحركين اكتيف صار.
والله انه كابتشر ذا فلاج منهم
يس
ذاك
يس.
النوع، فهمت. اصلا انا قاعد كنت من الناس اللي كان عندي تيم، وكنت ذاك النوع والله كانوا شباب صحابي ذيك ساعة. منهم واحد تونسي وواحد ذاك النوع من عندنا جزر القمر، رايح في كندا يشتغل. وكنا ذيك ساعة تيم، وكانوا هم يعدلوا ماستر، ذيك ساعة عدل ليسانس. وكنا دائما يعيطوا على الزيفينمون الوايل سايبر ولا شيء. كان عندهم ذيك ساعة مالي فتحنا كليب، وتوين قالوا سيكرينت، وتشوف عندنا ذيك ساعة عدلوا لي ديزيفينمون. فريمون ذاك النوع كانت
نايس.
مرحلة ذاك النوع من عمري تعلمت
تجربة
فيها ياس من
زينة.
الأمور. كانت فريمون ذاك النوع ذاك
مرحلة
النوع
زينة.
عنده فايدة.
يا اي سي. نايس
شوف
ان شاء الله.
من ذاك الوقت أنا نكمل فيها مستماشي نعوم بحري سفريات
اتس
غريبة.
فيري نايس. سبيشاليتي فاش في
أنا
أيوه.
نتوركينج ضركت احنا كان ضرك في سمستري. أنا ضركت حكما عد شفته هما هون بالنسبة لهم هما سيستم عالم الآخر ما هو واحد والله. بعد هون شفت لا يتعدل ذاك النوع السمستر الأول والثاني، لا تقرا فيه بلي انت هنا عندك ماستر قد تعدلوا على 6 سنوات.
اوكي. تعدلوا على 6
وأنا
سنوات كيف؟
قد تعدلوا موست 4 ذاك باشلور واللي قد تعدلوا على 6، قد تعدلوا على 4 سنوات.
هو نورمال على سنتين، قلت تمدوا لي على 4 سنوات.
حق بعد قلت هم اللي يدخلوا قاعد السنة الخامسة. شفت نحن هون كيف بار اكزامبل موديل يعودوا فيه ذاك تقريبا بار اكزامبل 3 موديل واحد يعودوا فيه ذاك 3 ماتير ولا 4 وضح له. كيت موديل يقولوا لك موديل يعطيك تجبر فيه تقريبا كيت بار اكزامبل موديل كريدي 15 يعطيك تجبر فيه ذي 15 ما قادرين ماتيرات تقبلت انت هما ما قادرين فيه، فهمت. بما انك تقبلته في رواية تقراها تعرف انك تنجح فيها تجبر فيه من ذوك سنتين ماتين تجبر فيهم 15 وضح له. أنا أنت ذاك موديل بار اكزامبل جبرت بلتوك 4 ماتشرات وجبرت فيه 30 أنت 30 ما محسوبة لك تحسب لك من اللي 15.
اوكي
فهمت السيستم.
اوكي
شوي ذاك النوع كومبليكي، فهمت. تسوي لذلك تاع مرات تعود يفرض عليك انك تفلتري ذاك النوع من ناحية اسم الواحد، ويجيك اللي مرات شي من المواد تعود لا تقراهم بازي على مواد اخرى وتسوي لذلك لا كأنك ذاك النوع، فهمت. عاد ذاك النوع لابد فهمت فيه سيلف ليرنينج وياس مش
اوكي زين. طيب فما تيامني المهم عندك فما اسم كلوبات شيء عن السايبر سكيورتي لكن عنهم هذه السنة الكوميونيتي سايبر سكيورتي خليك واحد قالوا سي عندي ما أعرف كاوس
هون محرمين ياس انت تروح بالاخص كاع برلين وهذا دائما
كندا عندك هذا اسطوري عنه ليجندري سي
ميديا سي خارج
كاوس كوميونيكيشن كونغرس
دائما يخرجوا في ديزيفينمون هنا تياو دائما هو اصلا من ناحية من ديك الناحية وراك فريمون.
فهذا عندنا ذاك نوع من الأولين المدرس وأنا خرج في ياسن ومر ليجندري ياسر
يضرك يا
سي كونفرنساتهم يسموا تسميتهم هي سي 39 سي والله هو سي 3
يسموها على دات.
وي سي 3 هو اسمه هو والآخر الثاني دات. أنا أول مرة نسمع به من ذاك اسمه الألماني والثاني لايف أوروفلو. أنا لايف أوروفلو تعرفون؟
أنا أعرف أنا لايف أوروفلو قد شفت فيديو منه قرمة ربما كنت
اوكي ذاك صار كنت نسوي ذيك الساعة شباب قاعد عايشين في الاستوديو
قط مرة ذاك نوع خالي فيديو والله شقر ما كابتيت ذاك نوع
اوكي هو ساد عنده ديك
وترى ذاك نوع
الساعة
ديك الزمن يا خويا كضرت بالبني ذاك نوع تجبر فيه لي زانفورماسيون تبيع مع تيت ذاك نوع
صحيح
التايمرات اللي تخلصت سكيبي
والله
يجيك واحد ذاك نوع مطولات ياسر وانا سبحان الله من الناس اللي نختار نقرا عن نختار نشوف رواية نختار نقرا رواية نختار نقرا رواية
اي سي فعلا قصيد قال هذيك الساعة بنادم حكم ريت تعرفيت 2017 ذاك نوع 18 17 ذاك وكان فيديوهات ذاك النوع هو اللي جبرت لي العافية استفدت ياسر قري ياسر الشيء مع اني ياسر الشيء ما كنت فريما انا كنت ديك الساعة كنت بداية ديك الساعة عندي سيزون والله تاكنا عندي
ما شاء الله يا بويا مش تمرق علي دخلت مدارك دخلت
ده باش ده تربى
انا بعد
تجربته
انا كومونسيت كاع ندخل دومين لا من الساعه اللي بدات الجامعه هو اللي كومونسيت ندخل دومين فهمت السابق ذاك كنت مفهوم الانفورماتيك عندي كان فريمون هذاك نوع فقير تراك نوع روايه ذاك النوع ديك ديك
بون انا بدايتي لا كتلود على احمد الحبيب شكال ديسا حفظ الشوارب وعفوا هذا بايس برسا وي شت نقول لك تقول صح وي انا بديت حكم بديت كوريج ذاك الوقت كتلود على الانترنت كيف اصبح هكذا خلق يموت تاكنا وذاك تنبني قادني على هذا لعبة فلو واللي دقيقة على فلو دي بدي ستاك استفدت شوية عن السي بي يو شنو تاكن ما يخلي اسم الروايات بيك اللي ما تقبل انت تقبل تقرر راسك تفتر بيك اللي ما تجبر شي فايت وتشك عنك عرفت شي انت ما تعرف شي تاكنو
ذيك هي المشكلة انك هي من اكثر والله من امتن
الروايات ما عندك حد
كيتيك انك قلت فلتري على الروايات اللي يعرفك
اكزاكتلي ما عندك حد كيتيك فاتي عاد يعرف ذاك حد تعب راسك انترنت من الناس اللي تعدل عنها تعرف شيء ذاك ما تقرا شيء والله
ادري ما حزتني كساب خلق واحد مرديك ساعه قلت لي خلق واحد يعطيك ساعه كنت بدايه تقريبا نقول لك انا دور سعود ديك 2019 كون 2020 ساعه بدايه جامعه ولا شيء وخلق واحد ديك ساعه عربي لبناني وكان دائما يكسان نسوي فيه وشك عنه من هذا قرايت فهم يطل وانا ذاك نوع زين عندي فهمت ذاك نوع كومونسيت ذاك نوع بالاخص ذاك نوع في بارتي سيكوريتي ديك الساعه نحن كنا نقراو نتوركينغ فهمتني وتوكين كومونسيت نفهم ذاك نوع ادريساج شنو هو ولي ماسك فهمت وذاك نوع طريقه دي ان اس كوما يشتغل دي اس بي والسيرفر ديك الساعه يشتغلوا على باكيت ريس ذاك نوع كوما تعدل ذاك نوع تبلدي ذاك نوع نتوركينغ ذا الشيء وتشوف كنت ديك الساعه عندي واحد مسويفي وكان دائما نقرا كنت ديك الساعه فريمون ذاك نوع متحمس خلق مرحله ذاك نوع والله بعد وعقبت وفيت ومشيت زاد كيف وجبرتش من الريسورس الاخرين واتواحد فيهم سميتني عاد النهارات سميتني نادم ورجعت لخلف فيديو هيك ساعه كان يتكلم عن ذاك النوع باينري ذاك نوع كان يتكلم عن باينري ذاك نوع اكسبلويشن ورجعت له تميت ثاني خلاص راعي لي بنادم اللي يتكلم عنه انا ذاك الزمن كان عندي روايه على باينري قبل كنت نشتغل عليها والله بعد كان عندي ذاك روايه يعطيني نكتبها عنها وتشوف راعي لي بنادم اللي يقول في نسبة تقريبا 60% من اللي يقول قاعد تقول عنه رجاج قاعد كل رواية مو فاهمها دائما تجبر ذاك انه يقرا وذاني انت ذاك انه كي تملي رواية مش ذاك انا تقتنع بها وتفهمها وبالاخص انت تفهمها خاسر هذا رواية كارثة
يب بتضيع وقتك وغدا كاسبة يعني خل طريق على طريق مدي ما هي مرسى طريق القراية تمداتش بعض النوع من
حتى لا نقول لك انا حتى طريق سكيورتي هاي ما يمرسل والله لا ما يمرسل
ست طريق سكيورتي به لي لا كراكر ياس قاع الناس اللي تعرفه تجبرني تسولف عن الطريق اللي قبله شنو هي فيه مليان اللام
يقول لك انا لا كان يقول ما نعرف كان خارج واحد اللي تعود تعرفه راه واحد مصري قال له مش إبراهيم الحجازي تعرفه؟
خالد اسم نعرف له
ذاك
الاسم
النادم.
نشوف شوي.
ذاك عنده هيك ساعة بودكاست ساعتين سيدي يتكلم عن
اها
أنا بودكاسته مجنون والله. البودكاست يقول هي اسم الكلام كان يشتغل عندنا مع ماستر كارد والله فيزا ما أنا واحدة منهم عندنا فيزا. وكان ذاك نعرض من السيناريو اللي كانوا يعدلوا فهمت في بن تيستينغ ولا شيء. المهم نادم ذاك نوع رجال فاهم هذا اللي كوش عنده
يا
شركة ذاك نوع قال دارك انتري. معناته كان قطش الدفتر دائما على تيليجرام على لينكدين. ذاك نوع بوست ذاك نوع
السيسي خالد هو ذاك عدي بي سكسسفول حتى دائما يشوف اسمه ما بعديك ساعة سكسسفول حتى سيتوب شيء زمان متحرك حتى في بق باونتي ما أعرف أقول لك مدال وفطارة ولا أقول لك مدال
الله يا الله يا
مدال بالنسبة لي أنا
والله
ديمين
أول هذيك لا بيريود قاع بودكاست له هندو. أنا كنت أصلا نعرف اسمه ذاك نوع قديم قد شفته مرة ذاك نوع كان يكسام انتي الفوق ذاك نوع بق باونتي قد مرة شفته أصلا قاع كان ذاك نوع كيف قد ذاك نوع مرة سويفيته على لينكدين كان بوستي رواية ديك الساعة تقريبا 2020. ان شاء الله همك تجي للمانيا.
وي انا وقتها متفاهم مع اللي هو الدكتوراه فاندينج اللي هو قلت يا وبوزيشنز بي اتش دي الدكتوراه خلاص اللي هو قلت يا
توفيق ان شاء الله.
ان شاء الله
توفيق.
شوفي رواية كلمة فيها مرة واحدة.
يعطيك الصحة. أنا يخليك أنا أخويا الوقت عندنا توخر الوحدة.
أوكي.
يعني أخويا ندير كذا على الصباح ندير معهم. الله يحفظك أخويا.
خير.
جزاك الله خيرا أخويا. إن شاء الله يعطيك الصحة. تشرفت بمعرفتك.
إن شاء الله شرف لي أنا.
إن شاء الله. الله يحفظك. مرحبا.
حمد مشى. أحمد. Let me invite Ahmed in here. كريم أحمد. محمد. Well. Anyways, okay, let's go. Let's continue on this journey. Yeah. At different time, we eliminate candidates whose probability falls below the short data elimination. لايف ياك ما عاد وافي هيو. لايف عاد وافي حتى اللي عاد 4 سباع خير. لكنه خاصني نقرأ هذه الباراجرافات واللي ظاهر يعني يلحقون تالي يعود المعروفات اللي هذا يزقل يعني ثاني تو نقدر الفكرة العامة حكما وضحت عيته في هذا يا غير ذواته مستنين موفق رأيتي الواي we know why in big Y. Who's that? We know why in Y. Yeah, the guy too. هكذا. No, ليش? At different time, eliminate candidates who at different time we eliminate candidates whose probability falls below a threshold theta elimination. What's that? Hello, يحيى. يعطيك السلام. Yes. Whose probability falls below a threshold theta matched to the natural ratio reduced by asymmetric loss. This outperforms training with a symmetric PCE and tuning theta elimination post hoc. Okay. This outperforms training with symmetric PCE and tuning theta elimination post hoc. No, I don't get. I still don't get what does this asymmetry mean. So let's continue. When no y is still consistent with x, the surviving set is empty and collapses y hat to bottom, which will push every candidate sigma towards 0 in a valid PC with conflict detection pressure. The lattice contains many representations of an empty solution set. We pick one that lives further up the lattice by caching the last non-empty y hat per chain and using x meets y hat left as PC's target once the surviving set becomes empty. This keeps conflict localized. I didn't understand what that means. This keeps conflict localized to an empty cells, where x is eliminated at every candidate. Y hat focuses the PC on sound detection within still satisfiable sets, and primarily leaves conflict detection to the CLS head. The candidate head can still flag localized conflicts when a cell collapses to empty. In our experiment, we use W plus W9 about W9 is equal to 8. Okay, and the site temperature, all tuned on Sudoku and transfer without modification to auto domains with value. Okay. عقيد pourquoi الواي يشتغل على Sudoku يشتغل على الثاني. I don't see any reason why it should happen. With the solution supervision via sigma operator. Many problems of interest admit lots of solution and lots of unique answer. Standard supervised okay. Let's use just parallel solve. Solve describes a single linear chain from the initial state to terminal. With the practice, we parallelize both training and inference. For training, we maintain pool of recent partially state okay. Tricks, inference tricks. At each step is wrapped in a random dataset level symmetry, a dataset mutation composed with dialog grid transformation. Which we invert after deduction and branching. We emit this augmentation during training. Where you found dataset level augmentation to perform better. The no-aug row type 1 is nether augmentation. The series showed that the inference is set slightly higher than training. Conflict head grows more. Okay. Yeah, I still don't get why evaluation Sudoku extreme. We evaluate seals puzzles that defeat every non-polynomial time. Puzzles are filtered to retain only instances that require search to solve, as measured by the Sudoku reported guess count per puzzle. This yields puzzles that defeat every non-polynomial time, human heuristic to enforce non-trivial backtracking depth on symbolic solvers. We train a 100k Lattice LDT on the 1000 puzzle training set using the procedure described in section 4.2. Sudoku extreme puzzles have unique solutions. Each instance is paired with a single ground truth solution. The alpha operator reduces to the k equal to 1 special case. We augment the training with symmetries of the Sudoku. of Sudoku. Any digit permutation in the diagonal group. Any digit. Okay. Acting on the grid, rotation, reflection, we find that tuning the conflict detection threshold during inference can slightly improve solver performance by reducing costs and avoiding timeouts. Specifically, okay. Compare methods with 3 frontier chain of thought LLMs. طبعا دي ما ينجحوا طبعا يا راجل في comparison والله يا غبر وايدي بابي. Additionally, we compare the two similar methods in theorem and HM. Okay. For theorem, we conducted zero-shot evaluations. For theorem, security reports. Okay, yeah. 0 طبعا 0. والله بوم. You can say that. HR قد يسوي haha TRM قد يسوي سوتاكو قد يسوي okay server 50 okay okay so this is interesting actually. Okay. Beyond the standard 99 grid, we evaluate snowflakes Sudoku. Okay. We evaluate. Okay. Yes. The أخبار Galva connections. Yeah, this makes sense. Okay. This is okay. Where is the code? Okay, guys, I think I'll stop here because yeah, because what a thing. Yeah, thanks everyone for coming, and that was lovely. That was lovely.